Assalamu alaikum. I am Tamanna Afroz. Welcome to our project data logger system where we detected humidity and temperature. We are going to start with the firmware of our project. For that we need to write code in Arduino. First we have to install the DHT library. For that we have to go to the library manager. For this we need to select the DHT sensor library from Sketch. Mine is already installed, that's why it will show installed. Now we will go to our code. First, the DHT library is included. We connected pin number 2 of Arduino with pin number 2 of DHT sensor. Then we selected DHT type 11. Our purpose is to print the humidity and temperature. Following that, we have our two functions which will read the temperature and humidity values from sensor. In the step up function, we selected a baud rate of 9600. Then in the loop function, variables are defined to read the humidity and temperature. The true function will give humidity and temperature value. If in any case the sensor fails to read this statement, it will print fail to read from DHT sensor, and if it works perfectly, the temperature and humidity will be printed. By defining a delay of 800 ms in the loop, we are ensuring that there is a delay of 800 ms between each measurement. Next part is the failed from, and then is the computation part. Lastly, temperature and humidity is printed. After finishing the code, we are going to save it. Then we will export compile binary by pressing Ctrl-Alt-S. This will generate our desired hex file in our selected directory, which will be used in Proteus, where we will do the later part of our project. At the end, I will again show the final outcome. Now my next groupmate will continue.
Hi, I am MD Abir Hassan. My ID is 18201019. In this part of our data logger system, I will show you the Proteus circuit part. So for the Proteus circuit part, we actually need 4 components. For the processing part, we need the Arduino Uno board. For calculating temperature and humidity, we will be using DHT11 sensor. To show our output, we have used virtual output terminal or virtual terminal. And for interfacing purpose, we have used COM physical interfacing module. Now let's see how we can get the components. So we just have to go to the component mode and write some keyword for our components. So for our desired components, so for Uno, I have written Arduino Uno, and we can get all our components from here. Now let's talk about the components individually. For DHT11 sensor, it actually has 3 pins. The first pin is connected to the power module, the last one is connected to the ground, and this second pin is connected to the resistor. What this second pin does is it is actually used for collecting data from this sensor. So what it does is we can see this second pin is actually connected to the input pin of this Arduino board. So what it does is Arduino collects the temperature and humidity data from this sensor through this line. Now let's see the virtual terminal. So here we can see there is a line that has been connected between the TXD port of Arduino and the RXD port of Arduino. So what it means is this TXD pin is actually used for transmitting data, and this RXD pin is actually used for receiving data. So we can see that it makes sense, because Arduino is actually transmitting the collected sensor data, and it is actually sending the data to this terminal, and terminal is actually receiving this data so that it can visualize the output. And for interfacing module, we have used COM physical interface module, which will be later needed for interfacing with LabVIEW. And we can see it is also using 2 port. But in this case, the RXD pin of COM pin is actually connected to the RXD pin of our Arduino Uno, and the TXD pin of COM pin is actually connected to the TXD pin of our Arduino Uno. Now let's see if our Arduino or this Proteus circuit is actually giving us the correct values. To do so, we actually need help from our previous Arduino part. So what we actually need is the hex code that has been generated from our previous Arduino code. So we have to select the hex file. So let's select the hex file. I have selected the hex file. Now let's run the simulation and see whether our circuit is giving us the correct value. So let's run it. Okay. So yeah, we can see that our circuit is giving us the temperature and the humidity rate. So let's see. We have selected the humidity rate. So let's change the humidity percentage, and we can see the changed humidity percentage here. The 82 is here, and now let's switch to Celsius, and let's decrease our temperature value. And we can also see, we have to wait a bit, and we can see that our terminal is giving us the correct desired temperature output. So we can see that our circuit is actually working perfectly. Now my teammate will continue with the LabVIEW part. Thank you.
Hello everyone, I'm Aditya. I have done the LabVIEW part of this project. So to begin with, I have opened a blank project in LabVIEW and then added the thermometer and the humidity meter from numeric thermometer and meter on the front panel. Then I have added 2 waveform charts from graphs waveform chart, one for the temperature and one for the humidity. After that, I have added a table from list table tree to show the outputs in a table format here. Next, on the block diagram, I've added a while loop in the first place. Then I've added visa clear to clear the input output buffers before taking any input. After that, I'm opening the input and getting two string inputs here. I'm reading the string inputs using this. Then I'm flashing the input output buffers again and closing the virtual instrument port. After getting the string inputs, I am converting the strings into numbers using this and showing them in the thermometer and waveform chart. I have done the same thing for the humidity waveform chart and humidity meter. Furthermore, I have built an array using the inputs along with date, time, and our IDs. And then I have inserted it into the array and get the output to the table control to show them in the table. So after everything, let's run the project. So here's the output. Here are the date and time and our IDs. The temperature and humidity is null for now as I haven't connected the LabVIEW with the Proteus using virtual COM port. This part will be shown by Tamanna Afroz in the next part of the video. Thank you very much.
Finally, I am back again to show the final outcome. Here we used virtual COM port to connect Proteus and LabVIEW. Here you can see the COM1 and COM2 is paired in virtual COM port. Selected COM1 in Proteus and COM2 in LabVIEW. Now we will run LabVIEW and turn on simulation for Proteus. The outputs are coming in LabVIEW and virtual terminal of Proteus. We can see that the outputs shown are correct. Now let's change the humidity and temperature to check if it is working properly. I will decrease the humidity and increase the temperature. It is seen that the values are changing accordingly. We can see the changes in the table and waveform. The thermometer and the gauge is also changing accordingly. So it is seen the whole thing is working perfectly.